So next chapter, work energy power. Okay. And about the test, ഏതാണ് loss of motion, there will be exam next week. Okay, next week, so there will be exam, so prepare well. Okay, tomorrow onwards you have to
Sir,
ah,
I have exams next week.
in school.
Yes, sir.
Okay, but some 5 or 6 questions at least you can do at home, right? In parents invigilation you can write the exam. Okay, ദിയ പാരന്റിന്റെ ഇൻവിജിലേഷനിൽ എക്സാം എഴുതിയാൽ മതി, കേട്ടല്ലോ? ഓക്കെ, ഒരു 5-6 ക്വസ്റ്റ്യൻസ് തരാം, ക്ലാസ് ടൈമിൽ വേണ്ട. സോ ക്യാൻ യു സീ ദ സ്ക്രീൻ? തൃഷ, ദിയ, ക്യാൻ യു സീ ദ സ്ക്രീൻ?
Yes, sir.
So next chapter, this is 5th chapter, work energy power. So I will send the PDF. So some questions are lengthy, so you need not write everything. Okay, I will send the PDF. After getting the PDF you can write work energy power. So in this chapter we will learn about work, energy and power. Okay, what do you mean by work? Anybody? Trisha, Diya, ഇത് ഓൾറെഡി എടുത്തതാണല്ലോ ദിയ, അല്ലേ? അല്ലേ?
Action that takes energy.
Action. Tell me again, how do you define work?
An action that uses energy and shows change.
Okay, that is correct. But in exam, if you write that definition, you will not get mark. In physics, listen, I will explain the meaning of work. Listen, there is a formula. Suppose there is an object here. Okay, there is an object. Let me begin with one simple example. It is kept on a surface. The body is lying on a surface. Body lying on a surface. I am applying a force. I am applying a force like this. F. You know that F, force is a vector quantity, right? Clear? I am applying a force like this. As a result, the body can move only in the horizontal direction. The body will not be moving like this, right? Because of its weight, the body unable to move along with the force. It cannot move in the same direction of force. Instead of that, it will be moving horizontally, right? Under this force, the body travel some distance. Some distance, the body reached this position. Okay, clear? Understood? You agree with me? Clear? Under the force, the body travel this displacement. The body has got a displacement. You know, displacement is also a vector quantity. Okay, it is a vector quantity. Let me remove the vector sign. F is the applied force, D is the displacement of the body. Is that okay? Till this step are you okay? Trisha, Diya, okay? Okay.
Yes, sir.
You know that the body can travel only in the horizontal direction, you know, because of the weight. It is restricted. The body is restricted to move in the horizontal direction. Suppose there is an angle between F and D. Okay, F is the applied force, D is the displacement. Let theta be the angle between the force and displacement. Then work, I am going to define work. Then work done by the force. Work alone does not have any proper meaning. Okay, work done by a force, now it is a complete meaning. Okay, work done by what force is equal to F into okay, what is the component of force along D? Can you tell me what is the component of force in the direction of D? Tell me. You know that F is rotated through an angle theta. So the work done by the force, let me write it in sentence. Work done by the force is equal to the component or part of the force. The component of the force in the direction of motion, in the direction of displacement, into the displacement of the body. In this way we define work done by the force. The component of force in the direction of the displacement, look here, look at this picture. The component of F in the direction of displacement is F cos theta. Correct alle? Clear? Dishatriya, you agree with me? Correct? F cos theta into displacement is denoted by D, right? So remember, this definition is very, very important. The component, the part of F in the direction of displacement into displacement. Why the component of F in the direction of displacement is used? Because F has two components. One is in along the direction of the displacement. Other one is the perpendicular component. F sin theta will be there. But this F sin theta does not have any role in the motion of the body. Clear? This perpendicular component has zero influence on the motion of the body. Whatever be the vertical component, it has no role in the motion of the body. Hence we reject F sin theta. We reject F sin theta. Only this horizontal component of F has the role in the motion of the body. Hence we reject F sin theta. Only F cos theta is taken. Clear? F cos theta into D is the work done by the force. Or F cos theta, F d cos theta. Okay, in symbol form, symbolic form, W equal to F into D into cos theta. F is the applied force, D is the displacement, theta is the angle between F and D. All of you clear? Understood? Okay. ദിയക്ക് മനസ്സിലായല്ലോ അല്ലേ? ദിയ ക്ലിയർ അല്ലേ?
മനസ്സിലായി.
And what is a unit of work? Can you tell me what is a unit of work? Work in the unit joules അല്ലേ? പഠിച്ചിട്ടില്ലേ? joules. No response. Denote by J. Dishatriya audible അല്ലേ? So you can write or you can write it later. So work done, you understood work done. So work done by the force. Okay. And it has several applications. The concept work done has lots of application. Using this concept we can understand the nature of the motion. What is the velocity at different time intervals? We can answer several questions by simply knowing the concept work done. Okay, that part I will explain later. Okay, complete ayo. Diya, Trisha, have you finished? Okay, so let me go to next page. And okay, so I hope you understood. So let me explain one problem. Let me explain one question. This question is I give preference to numericals. Theory part, if you have the textbook you can read the theory part. It's not difficult. The numericals is the main thing in all chapters. So I give preference to numericals. Example, a cyclist comes to a skidding stop in 10 meter. A cyclist comes to a skidding stop. I mean, due to the friction of the road. Clear? The friction on the road, the cyclist stop after traveling 10 meter. During this process, the force on the cycle due to the road is 200 Newton and is directly opposed to the motion. How much work does the road do on the cycle? How much work does the road do on the cycle? How much work does the cycle do on the road? Have you understood the question? Diya, Trisha, have you understood the question? മനസ്സിലായോ? Okay, if you don't understand, draw a rough picture. I don't want to draw a beautiful picture of the cycle. Okay, ഞാനിങ്ങനെ ഒന്ന് വെറുതെ ഒന്ന് ട്രൈ ചെയ്ത് നോക്കാം. Okay, I am not I cannot draw the cycle. ഇങ്ങനെയൊന്നും വേണ്ട. Okay, let it be this one is the cycle. Okay, this is the cycle. A cycle is moving along a horizontal road. It is moving like this. It traveled how much distance? It travel a displacement of 10 meter, correct? 10 meter. The cycle is moving on a rough surface, clear. There is friction. There is a friction as the cycle is moving towards right. The frictional force opposes the motion, clear. The friction is constantly applying on the cycle. That frictional force F is equal to 200 Newton. Is that okay? Clear? All of it clear?
Yes, sir.
But the body is moving towards right, clear. The body has got a displacement towards right, but during that motion the frictional force applied towards left. Okay, so let me so first part is how much work does the road do the cycle. Road എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ how much work done by the frictional force അതാണ് ഉദ്ദേശിച്ചത്. Road is actually doing the frictional force, അല്ലെ, applying the frictional force. So the first part is nothing but work done by the frictional force, clear. Work done by the frictional force. All of it clear? Understood? Understood?
Yes, sir.
Okay. You just write the formula. Work done, the formula is FD cos theta. You understood? Clear? Work done by a force is FD cos theta. Okay. Diya, Trisha, you got the idea? Understood?
Yes, sir.
So cos theta, most of the students forget to write cos theta. So F is the frictional force, it is 200 Newton. I am writing only magnitude, okay? D, magnitude of the forces F and D to be written. D is the displacement traveled by the cycle, it is 10 meter. Now cos theta has a role here. Cos theta എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is the angle between the force and the displacement. Is that correct? Clear? The frictional force is towards left, but the displacement is towards right. You understood? Clear?
Yes, sir.
So the angle between these two vector is 180 degree. In exam you have to write all these steps, okay? You agree with me? Clear? Theta, angle between force and displacement is 180 degree. Trisha, you understood? Trisha?
Yes, sir.
Okay, so cos 180 will be there. What is the value of cos 180? You studied in trigonometry, right? All of you have opted maths subject, right? Maths eduthittille Diya?
Yes, sir.
What do you mean? What is cos 180? Can you tell me? Cos 180?
Cos 90 വരെയാ പഠിച്ചത്.
അതെയോ? എന്നാലേ അത് പഠിച്ചു വെച്ചോ, ഓക്കെ? If you don't know, please memorize. Cos 90 degree 0, അത് ഇവിടെ ആവശ്യമില്ല. But cos 180, you please memorize the value -1. Up to 180 degree, you must memorize. Okay? If you don't know, please write somewhere. Trisha, Diya, okay? Understood? Cos 180 degree -1 ആണ്. Okay? Clear? No response?
Yes, sir.
Yes, sir.
So 2000 into cos 180 -1. Please memorize the value. In exam this value will not be given, so minus 2000 joules. Okay, so
Force opposite direction ആവുമ്പോ മൈനസ് ആവില്ലേ?
അല്ല, in FD cos theta I am writing only the magnitude. Okay, in the formula FD cos theta I write only the magnitude. I don't want to show the negative sign. നെഗറ്റീവ് സൈഡ് നമുക്ക് കോസ് 180 എന്ന് കിട്ടുന്നുണ്ട് സെപ്പറേറ്റ് ആയിട്ട്, അല്ലേ? Trisha, clear? Trisha, understood?
Yes, sir.
Okay, so what is the second question? What about the second question? How much work? It is a tricky question, second one. How much work does the cycle do on the road? Cycle do on the road. Anybody tell me? what happens to road? Cycle is moving, cycle doing some work on the road. The work on the road will be zero because the road does not travel. Road does not move. Clear? As the cycle moving, okay, cycle may be doing some work on the road. Cycle may be doing some work on the road, but the road does not move. Work done will be there will be work done only if the body move. Here the road does not move. Clear? The road does not move, so work done by the cycle on the road. Ft cos theta is there, but the displacement, the road has got zero displacement, so it will be 0 joules. Work ഉണ്ടാവണമെങ്കിൽ there will be some displacement. Here the road does not travel, the road is fixed, so work done on the road will be 0. Clear? Understood?
Yes.
Yes, sir.
Okay, so tell me if you have finished. You can write later. This question is taken from textbook. Okay, so finished. The next one, this one I will discuss later. This is about kinetic energy. So next, so work done is clear to you. The next heading is we will learn more about energy, but for the time being let us learn an important type of energy, kinetic energy. There are different types of energy. Other one is potential energy, but I will explain that energy later. But this kinetic energy is required, we have to learn right now. Without kinetic energy I cannot explain work energy theorem. That's why I am defining kinetic energy. Actually you studied this kinetic energy in the lower classes, Diya, Trisha, how do you define kinetic energy? How do you define kinetic energy? No response. Hello, you studied in, you have already studied, right?
Sir, it's the force that an object will possess due to motion.
No, kinetic means energy due to motion, that's all. Its definition is very simple. Kinetic energy is defined as the energy I don't want to explain. Okay, you have already learned about energy. Okay, the energy of the energy possessed by the body. Energy, yes, possessed, adana correct word. Possessed by the body due to its motion. It is said to be kinetic energy. Kinetic means motion. If a body is moving, it carries energy. You agree with me? A body having mass m and moving with some velocity v, it carries some energy. Why it carries some energy? Because if this body hit on any body, it will do some work. Clear? This moving body is able to do some work. അതായത് ഇപ്പോൾ for example this body hit on something. Clear? That body will be moving because of its motion. So every moving body carries some energy, means that it can do some work. Understood? Clear? Okay.
Yes, sir.
So the okay, I don't want to elaborate, I don't want to spend time on this. So energy possessed by the body due to the motion. The more mass results in more kinetic energy. The more velocity also results in more kinetic energy. The kinetic energy is defined by this formula. Its proof is not required because it is not even mentioned in textbook. We define this formula due to certain reason. That reason you can understand when we learn work energy theorem. When we learn work energy theorem, you can understand why we define the formula like this. Okay, So kinetic energy depends on mass and velocity. The more mass and velocity results in more kinetic energy. So kinetic energy formula will be half mv square. Unit is same as joules. Due to a body having kinetic energy means it can do some external work. That's all. Okay, all of it clear? Diya, Trisha, understood? Kinetic energy is okay.
Yes, sir.
Okay, so can I go to next page? Kinetic energy clear ആണ്.
Yes.
അവിടെ ഓൾറെഡി പറഞ്ഞിട്ടുണ്ട്. Let me explain one question. I will discuss some selected question. Actually, it is there in NCERT book. Please read this question. Let me read this question. I will discuss some selected numericals, important ones. In a ballistics demonstration, a police officer fires a bullet of mass 50 gram with a speed 200 meter per second on soft plywood of thickness 2 centimeter. The bullet emerges with only 10% of the initial kinetic energy. What is the emergence speed of the bullet? It's a little bit hard, but I will explain. Listen, all of you please listen. What is that? Plywood is there. Okay, plywood. What is plywood? It is wood actually. It is similar to wood, having certain thickness, some thickness. Clear? Okay, there is a plywood having some thickness. The thickness is given as 2 centimeter. Clear? Understood?
Yes, sir.
Okay. A bullet is fired in a demonstration. A bullet is fired on this plywood. The bullet. This one is bullet. If I fire a bullet on this plywood, definitely it will cross because the plywood is not so strong. It will cross the plywood. Its thickness is only 2 centimeter. The bullet can easily cross. Okay, gap. The bullet is coming with some initial velocity. Is it given? Yes, it is coming with the initial velocity u or v1, whichever letter you can use, no problem. 200 meter per second. The bullet is going to hit the plywood with a speed of 200 meter per second. Okay, you agree with me? Clear?
Yes, sir.
Okay, and after that, after crossing this plywood, what happens? Its kinetic energy is reduced, has only 10% of the initial kinetic energy. Let me I will substitute u equal to 200 meter per second later. The body has the initial velocity v1 and final velocity v2. The bullet has mass m. After crossing this plywood, the same mass. Clear? The bullet will not be broken. So the bullet having mass m is approaching the plywood with a velocity v1 and it crosses the plywood and after crossing its velocity becomes v2. Okay, till this step are you okay? Clear?
Yes, sir.
Okay, so it is given that final kinetic energy. Please read this question carefully. It is given that final kinetic energy is equal to 10% of initial kinetic energy, because lots of energy will be lost in the form of sound energy, heat energy, etc. Clear? The final kinetic energy is given as 10% of the initial kinetic energy. It is given in the question. This step is okay? Clear? Okay, the Trisha, Diya.
Yes,
Okay,
sir.
let me begin with this equation. Tell me, what is the final kinetic energy formula? Tell me. Final kinetic energy formula will be You don't know? Final kinetic energy, formula of kinetic energy I have already explained. Half mv square. So final kinetic energy will be half into m into v2 square. Is that okay? Please respond. Trisha, clear?
Yes.
It is equal to 10% of. 10% means 10 by 100, correct? You studied in the lower classes. 10% means 10 by 100 times 10% of means 10% into initial kinetic energy is half into mv1 square. Okay? Are you okay? This step is clear to you?
Yes, sir.
Yes.
So can I cancel any terms left and right? Yes, I can cancel. Look here. This 1 by 2, 1 by 2 cancel. Mass of the bullet cancel. What is left? V2 square is equal to 10 by 100 is 1 by 10. Is that okay? 10 by 100 is 1 by 10 into V1 square. Now it is very easy to solve. Clear? Till this step are you okay? Till this step are you okay? What is our question? Please read the last sentence, you can understand that. Our question is, what is the emergent velocity, emergent speed? V2 is our question, correct? V2 is our question. So substituting V2 square will be equal to 1 by 10 into V1 square. V1 is given in the question, correct? The initial speed of the body 200 meter per second. So V1 square എന്ന് പറയുമ്പോൾ 200 into 200, correct? 200 square. Understood? Clear? No response. Okay. So V2 square you can easily find out. 10 cancelled. You 4000. 4000, correct? Yes, you can check it. Yes, correct. 20 into 200, 4000. Yes. So if you don't have the calculator, you can write at least this step. Root of 4000 can be written as 400 into 10. Can I write 4000 as 400 into 10? Clear?
Yes, sir.
Okay, so 1 minute. I hope you understood. 1 minute. In this question, if it is a numerical question asked in exam, this root 10 will be given in the problem. In textbook they have not given, but in exam if there is a question like this, definitely they will give the some approximate value of root 10. Let me write that. Okay, use root 10 equal to 3.16. In physics that kind of value will be mentioned in problem. So I want v2 final velocity. So in this question root 420, you agree with me? Trisha, Diya, you know, do you know that? Root
Yes,
400. Root 400 is 20. But root 10 is there. I don't know that value. Okay. 20 root 10 I can write. 20 root 10. 20 into root 10 is given in the question 3.16 approximately. So this will be 6.32. Sorry, 63.2 meter per second is the emergent speed, or final speed of the bullet. Clear this problem? Okay, understood? Both of you clear?
Yes.
So you can write later. Okay, it is taken from textbook. ദിയയ്ക്ക് എന്തെങ്കിലും റിപ്പീറ്റ് ചെയ്യണോ? ദിയ ഇത്രയും പറഞ്ഞതില് ദിയയ്ക്ക് മനസ്സിലായോ? മനസ്സിലായി. തൃഷ അണ്ടർസ്റ്റുഡ്? തൃഷ, you understood?
Yes, sir.
Okay, this problem is clear. So next, so I explain the formula work, and after that I explain kinetic energy. Is there any connection between work done and kinetic energy? Yes, definitely. So next heading is very very important one, work energy theorem. It's a very important theorem. Two proofs are given in textbook, but you learn at least one proof is required. One proof is enough. Two proofs are available in textbook. Work energy theorem. ദിയയ്ക്ക് അറിയാമോ വർക്ക് എനർജി തിയറം? ദിയ, The
മറന്നുപോയി.
മറന്നുപോയി. Trisha, do you know work energy theorem? Trisha?
No, sir.
No idea. Okay. Listen. There is a body having mass m. Okay. There is a body having mass m. This body is moving on a horizontal surface. Okay. Suppose this body has the initial velocity u. The body has initial velocity u. Now I am applying some constant force. I am applying what? Some constant force F on the body, so that I want to increase the speed. To increase the speed, I am pushing this body towards right by applying some a fixed force F. And remember, this force can be a variable force also. Variable എന്ന് പറഞ്ഞാൽ വേരി ചെയ്യുന്ന ഫോഴ്സ്. My objective is I want to increase the kinetic energy. Increasing kinetic energy can be achieved by increasing the velocity, correct? So initial velocity u, and because of the constant force F, its final velocity becomes u. F is the constant force. Every time I am pushing the body so that I want to increase the kinetic energy. The body initially speed was u, finally the speed becomes v. During that period, the body travels some displacement, say s or d. Okay, you can use any letter, no problem in that. The displacement s എന്ന് എഴുതിക്കോട്ടെ. The body, normally we use displacement by denote by s അല്ലേ, ശരിയല്ലേ? Clear?
Yes,
Till
sir.
this step, are you okay? Picture is okay? Understood? Trisha, Diya, picture is okay?
Yes,
Okay.
sir.
So what is the purpose of force here? The purpose of force is for increasing kinetic energy, because as the force is applied, definitely it has got acceleration. The velocity will be increased after moving some displacement s. So let me begin with the equation familiar to us. Or okay, one minute. Yes. Let me begin with one formula which is familiar to us. We have studied that. Have you studied this formula? V square equal to u square plus 2as. ഇങ്ങനെ ഒരു ഫോർമുല പഠിച്ചിട്ടുണ്ടോ?
Yes, sir.
ഇല്ലേ? Trisha, have you studied this in the chapter
Yes, sir.
motion in a straight line? We have studied. Yes. The body is moving with a fixed acceleration a. Because there is a force, the body experiences an acceleration. Now I want to make some modification in this question. Multiply both sides. Let me write all the steps. In exam you have to show all steps. Multiply each sides by half into m. Why I multiply the half into m? Because I want to express in terms of kinetic energy. That's why. Multiply each side by half into m. So left side is multiply with the half into m, gives half mv square. Right side half m is taken inside the bracket, correct? Half m is taken inside the bracket. Half m u square plus half m into 2as. Is that okay? Trisha, Diya, you understood?
Yes, sir.
Okay. Trisha, clear? രണ്ടുപേർക്കും clear ആണ്. 2 cancels. Can I cancel 2 both sides? Yes. Numerator and denominator 2 cancel. Now let me take this half mu square to the left hand side. Okay, half mu square is taken to the left hand side. We get half mv square minus half mu square is equal to right side ma into s. Let me put a small bracket here, ma into s. Is that okay? Till this step, are you okay? Till this step?
Yes.
Okay. Then next right side, what is this ma? Trisha, what is this ma?
Force.
Force. So right hand side is force into displacement. Here I have taken a simple situation, force and displacement having the same direction. So if ma is F, so the right side is F into S equal to half mv square minus half mu square. Force into displacement is work. Force into displacement into cos 0 will be there because angle between force and displacement is 0. Cos 0 it will be 1. I don't want to show the cos 0 here. Force into displacement. Force is in the direction of the displacement. So force into displacement is the work done. Force into displacement is the work done equal to right side is half mv square minus half mu square is changing kinetic energy. Clear? You understood? All of you clear?
Yes, sir.
Work done by the force. Work done by the force. This force can be fixed force or variable force. Work done by the force is equal to changing kinetic energy. Kinetic energy. This is a very important theorem. This theorem is said to be work energy theorem. Work done by the force. Please note that the force can be fixed force or variable force. But here I derive using a fixed force, variable force. So work done by a force is equal to change in kinetic energy. Okay, clear? All of you clear? Diya, Trisha.
Sir.
Okay. Please read this. Please read this derivation right now. Tell me if you have completed it. Okay. If you have any doubt in any steps, please tell me. I will explain that. Okay. Clear?
Yes, sir.
Understood. And here we have a one tough question. It is actually taken from NCERT, but I must discuss this because it is taken from exercise. It is I cannot skip. It is hard question, tough question, I agree, but this question is taken from NCERT. You see 5.20 exercise question. So work energy theorem has a lot of applications. Please read this question, then only you can understand that problem. A body of mass 0.5 kg travel in a straight line with the velocity v equal to a into x raised to 3 by 2. Okay, here if the calculator is not if the any value is not given, you need not do the simplification. Okay, a body moving with the velocity v equal to a into a is 5 is given in the question, v equal to 5 into x raised to 3 by 2. What is the work done by the net force during the displacement? Let me ask you one thing, Diya, Trisha, after 12th standard, do you want to write NEET exam? NEET?
No, sir.
No, I'm just asking, okay? Actually, this question was asked in NEET exam. That's why I just asked, okay? Trisha, Diya, both of you are not planning to write NEET exam, okay? I'm just asking, okay? Okay, so let me explain. എന്താ
ചിലപ്പോൾ എഴുതുമായിരിക്കും.
ആ ഓക്കെ, കുഴപ്പമില്ല. ഇപ്പോഴേ തന്നെ ഒരു പ്ലാനിങ് വേണം കേട്ടോ. 2 വർഷമല്ലേ ഉള്ളൂ അല്ലേ, 1.5 വർഷം, 1.5 years. എ ബോഡി എഞ്ചിനീയറിംഗ് ആണല്ലേ, ഓക്കെ. ഈവൺ ഇൻ എഞ്ചിനീയറിംഗ് യു വിൽ കം അക്രോസ് ദിസ് കൈൻഡ് ഓഫ് പ്രോബ്ലംസ്. ഇറ്റ് ഈസ് എ ചലഞ്ചിങ് ക്വസ്റ്റ്യൻ, ചലഞ്ചിങ് വൺ. Okay, Trisha, the question have you understood? Let me draw a rough picture. If you don't draw the picture, You will never be able to understand the question. A body has mass. What is the mass of the body? 0.5 kg. Correct? Clear? Trisha, Diya?
Yes, sir.
Yes,
This
sir.
body moving with the different velocities at different positions. It is clear from the question. The body is not moving with a fixed velocity. The body having velocity velocity v equal to a into, given in the question, it has a variable velocity. At different positions it has different velocities. Just like a car, if the car is moving along a straight line, do you believe that the car is moving with a fixed velocity every time? No. At different positions, car will have different velocities. If there is a slope, okay, road has some slope or descending road, there will be variation in velocity, right? അപ്പോൾ ഞാൻ പറഞ്ഞു എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ദ വെലോസിറ്റി ഇസ് നോട്ട് ഫിക്സഡ്, ഡിഫറെൻറ്റ് വെലോസിറ്റി ഫോർമുല ഈസ് ഗിവൺ ഇൻ ദ ക്വസ്റ്റ്യൻ. വെർ ഇസ് ദാറ്റ്? വി ഈക്വൽ ടു 5 ഇൻറ്റു, കറക്റ്റ്, A5 അല്ലേ, വി ഈക്വൽ ടു 5 ഇൻറ്റു എക്സ് റൈസ് ടു 3/2, വേർ എക്സ് ഈസ് ദ ഡിസ്റ്റൻസ് ട്രാവൽ ബൈ ദ കാർ. ഞാൻ ഇതിനെ കാർ എന്ന് തന്നെ വിളിച്ചോട്ടെ. എ കാർ ഈസ് മൂവിങ്, എക്സ് ഈസ് ദ ഡിസ്പ്ലേസ്മെൻറ്റ് ട്രാവൽ ബൈ ദ കാർ. എക്സ് എന്ന് പറഞ്ഞാൽ ഡിസ്പ്ലേസ്മെൻ്റ് ആണല്ലോ, എപ്പോഴും അങ്ങനെയാണ്. X is the displacement traveled by the car. The velocity depends on the displacement by the formula v equal to 5 into x raised to 3/2. Initially the position of the car is x equal to 0, given in the question. Initially the car എന്ന് തന്നെ പറയുന്നത് ഒരു ക്ലാരിറ്റിക്ക് വേണ്ടിയാണ്. Initially the car has displacement or position 0. After traveling some distance, the car has the new position x equal to 2 meter. അതായത് കാർ ട്രാവൽ 2 meter but having different velocities. The mass is 0.5 kg. The car has different velocity because it is experienced by a variable force. അല്ല, എങ്ങനെ എന്തോ ഒരു there will be some variable force constantly acting on the body. As a result, the body is getting different velocities. But I have no idea about this force. Some force will be there. As a result, body is moving. Alle? Okay? All of you clear? Till this step, are you okay?
Yes, sir.
Yes, sir.
So, work done equal to force into displacement. We have studied that. But here this force is not a fixed force, it is a variable force. So Ft cos theta can be used only for the fixed force. Work done equal to force into displacement. We have a formula, force into displacement, but such formula can be used only for a fixed force. ഇവിടെ ഫോഴ്സ് ഈസ് നോട്ട് ഈവൻ ഗിവൺ അല്ലേ, ഫോഴ്സ് തന്നിട്ട് പോലും ഇല്ല. ഡോണ്ട് വറി, വർക്ക് ഡൺ ഹാസ് അനദർ മെത്തേഡ്. വർക്ക് ഡൺ ഈക്വൽ ടു ഫോഴ്സ് ഇൻറ്റു ഡിസ്പ്ലേസ്മെൻറ്റ് ഈസ് വൺ ഫോർമുല, ആൻഡ് അനദർ ഫോർമുല ഫോർ വർക്ക് ഈസ് ഫൈനൽ കൈനറ്റിക് എനർജി. വി ഹാവ് സ്റ്റഡീഡ് ദിസ് ഫോർമുല, വർക്ക് എനർജി തിയറം മൈനസ് ഇനീഷ്യൽ കൈനറ്റിക് എനർജി. യു അഗ്രി വിത്ത് മീ? Understood?
Yes, sir.
Trisha, okay. So if force is not if the fixed force is not available, don't worry, work done is equal to change in kinetic energy, final kinetic energy minus initial kinetic energy. For the simplification purpose, half m is common in both the terms, so let me take half m outside so that we will be able to simplify that. v2 square minus v1 square. Is it okay? All of you clear?
Yes, sir.
Diya, manasilayo Diya? Okay?
Yes, sir.
Let me substitute the value half into m. What is the mass of the body? Mass remains fixed. Mass of the body 0.5 kg. m is 0.5. v2 square. v2 is the final velocity, correct? അല്ലേ, ശരിയല്ലേ? v2 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is the final velocity and v1 is the initial velocity, correct? Okay, understood? No response.
Yes, sir.
Okay, let me find out V1 and V2 separately. That is much better. V1 and V2, I am going to find out V1 and V2 separately. We have a formula that V equal to 5 into x raised to 3 by 2. Correct? We have a formula for finding velocity. Velocity equal to 5 into x raised to 3 by 2. So initially the body is at x equal to 0. Correct? Initially the body's position is 0. So initial velocity V1 will be 5 into 0 raised to 3 by 2. We have a formula velocity equal to 5 into x raised to 3 by 2. Initially x equal to 0 is given in the question. So substituting x equal to 0, we get initial velocity 5 into 0 raised to 3 by 2. All of you clear? Understood?
Yes, sir.
Trisha?
Yes, sir.
Okay. You know that 0 raised to any number 0, right? Clear? 0 raised to any number will be 0. So V1 equal to 0. It is required. Let me write it somewhere. So initial velocity 0. The body travel from rest. Clear? And I want the final velocity V2. The velocity, the formula is 5 into x raised to 3 by 2. In the final state, x is 2 meter. Correct അല്ലേ? ഇവിടെ എത്തുമ്പോൾ എക്സിൻ്റെ വാല്യൂ 2 ആണ്. So substituting x equal to 2, we get the final velocity. Substituting x equal to 2. 5 into 2 raised to 3 by 2 is the final velocity. Correct? Clear?
Yes, sir.
Trisha?
Yes, sir.
Okay. So V2 square minus V1 square. V2, what is V2? Yes, V2 is written 5 into 2 raised to 3 by 2. 5 into 2 raised to 3 by 2 all square minus. V1 square is there. V1 is 0, correct? So 0 square. Okay, I hope you have understood. So the next step is half into 0.5. Half into 0.5 into squaring means multiplying twice. Or 5 square. 5 square into this word square. 5 square is 25. You know that. 5 square is 25. Into 2 raised to 3 by 2 square. 5 square into 2 raised to 3 by 2 square. 2 raised to 3 by 2 square. Clear? Diya, Trisha, both of you clear? Hello? Clear? Understood? Hello?
Sir, can you repeat it, please?
I will repeat. Which step you have a doubt? Diya kekamo? Diya?
Keka, sir.
Trisha, listen. Have you understood this step, Trisha?
Yes, sir.
Okay. Now next step is this half is there, correct? This 1 by 2 written as it is. This 0.5 is written as it is. And here, can you see 5 square? Trisha, can you see 5 square? Yes. That 5 square becomes 25. You understood? 5 square becomes 25. Into 2 raised to 3 by 2 square also there, correct? 2 raised to 3 by 2
Yes,
square is also there. That is written here. 2 raised to 3 by 2 square. Both of you clear?
Okay, sir. Yes, sir.
So
Yes,
1 by 2 into 0.5 into 25 into 2 raised to 3 by 2 square. Actually you studied in smaller classes, 7th standard. It's a simple mass. Raised to, again raised to. If raised to comes twice, 2 raised to 3 by 2 raised to 2, correct? If the raised to appear twice, you just multiply them, correct? Studied in the lower classes. You just multiply the powers. 3 by 2 into 2, correct? 3 by 2 into 2 will be 3. The step is also okay?
Yes,
Clear?
sir.
Okay. Trisha? Okay. So actually I am writing all steps. 1 by 2 into 0.5 into 25. Okay, you can do some cancellation here. 8 by 2, you can see that 8 by 2, 8 2 cube 8 aanallo. 8 by 2 is 4 into 0.5 into 25. This will be 50 joules. You know, the unit of work is joules. I don't want to explain multiplication. 50 joules of work is done by that variable force. So if the force is variable force, we can use work energy theorem. Change in kinetic energy is the work done. If the fixed force F is given, okay, F into D, force into displacement, you can use. So this problem is okay. All of you clear?
Yes, sir.
So please read all the steps. If you have any doubt in any step, please tell me right now. If you have read everything, you can tell me. I will go to next problem.
കഴിഞ്ഞു sir.
കഴിഞ്ഞു. Trisha?
Done, sir.
Done. Okay. So work energy theorem you understood. Yes. Potential energy I will explain in the next class. 1 minute. And remember, there is one theory. A question is not there is just a theory. That part I want to discuss. Next is work done by a variable force. Work done by a variable force. Graphical method. Why graphically? Because we have a formula. Even if the force is variable, work done by the force is change in kinetic energy. We have studied two formula. Work done equal to force into displacement. If the force is not a fixed force, work done, I can use this formula, change in kinetic energy. Final kinetic energy minus initial kinetic energy. That algebraic method we are familiar, but I am going to explain the graphical method. Okay, clear? Work done by a force. Let me change the heading, title. Work done by a force. Fixed force or variable force. The force can be fixed or variable. How to find the work done by a force graphically? The force can be either fixed or variable. You understood? Clear? Okay? Okay. So I am explaining the graphical method. The algebraic method we have studied, force into displacement or change in kinetic energy. So a graph is given to you. The graph will be given to you here, x-axis and y-axis. In x-axis represents the displacement. X-axis represents displacement. For a better clarity, let me write some number over here. 1 meter, 2 meter, 3 meter, like that. Otherwise you will forget everything. X-axis represents the displacement traveled by the body. Okay, all of you clear? Displacement traveled by the body, 1 meter, 2 meter, 3 meter, etc. Different position. Clear? Displacement athava position nu parayato. Position of the body is represented by x-axis. Okay, clear?
Yes, sir.
And y-axis, this is what y-axis represents force. Remember, y-axis represents what? Force. For a better clarity, let me write some number over here. 1 Newton, 2 Newton, 3 Newton, etc. etc. So x-axis, the position of the body is given. Y-axis, the force on the body is given. So for different positions we are applying different forces generally. അല്ലേ? ഡിഫറെൻറ്റ് പൊസിഷനിൽ വി ആർ അപ്ലൈയിങ് ഡിഫറെൻറ്റ് ഫോഴ്സസ്. സപ്പോസ് ദ ഗ്രാഫ് ഈസ് ഗിവൺ ടു അസ്. Suppose the graph, let it be a variable graph like this. Okay, you know that if the car is moving, practically speaking, if the car is moving, you know, at different positions of the car, the force will be different. You agree with me? So I'm showing the variable force. Different positions, we have a different forces. Till this step, are you okay? Clear?
Yes, sir.
Okay, so my objective is initially the position of the car or object, let it be x1. വെറുതെ 1 meter 2 meter വെറുതെ ക്ലാരിറ്റിക്ക് വേണ്ടി എഴുതിയതാണ് കേട്ടോ. ആൻഡ് ഫൈനലി ദ പൊസിഷൻ ഓഫ് ദ ബോഡി, ലെറ്റ് ഇറ്റ് ബി x2. എന്തെങ്കിലും ഒരു നമ്പർ കൊടുത്തെന്ന് മാത്രമേ ഉള്ളൂ കേട്ടോ. ഓക്കെ, so the body travel from the position x1 to position x2 under a variable force. അല്ലേ? ബോഡി ട്രാവൽ ഫ്രം പൊസിഷൻ x1 to final position x2 under a variable force. So this force can be geometrically found by using the area under this curve. Clear? അല്ലേ? ഇവിടെ ഒരു ഏരിയ ഉണ്ടാവില്ലേ? ഏരിയ അണ്ടർ ദ curve, there will be some area, right? Clear? This area, ഇവിടെ ഇങ്ങനെ കാണിച്ചാൽ മതിയല്ലോ. This area will be equal to work done by the force. So understood? So work done by a force, graphically how will you find the work done by a force? First of all, this graph will be given in the question. At different positions we are applying different force on the body. We get a continuous curve like this. Force versus displacement, I got a continuous curve like this. Area under this curve from the initial position to final position represents the work done by the force. All of it clear? Understood?
Yes, sir.
Yes.
There is no question on textbook, but remember, in exam if they ask question, this one will be a familiar curve like this. For example, in lower classes you have studied area of triangle. Understood? Have you studied area of triangle? Have you studied so if suppose this question is asked in exam, the curve will be either a line like this, so that you will be getting a triangle or rectangle. Some familiar picture will be there. Okay, familiar picture will be there if it is asked in the exam. So please note this formula. Question is not there in NCERT. Okay, please write down or please read this. If you have any doubt, please tell me. Okay, clear? Trisha, Dia?
Yes, sir.
Yes.
Okay, then let me wind up the session. Okay, bye. Okay, bye. I will send the PDF.